CERN just opened a portal to another dimension, and the world's smartest kid is here to expose the terrifying truth. Forget everything you think you know about reality, because Max Laughlin believes the universe as we know it has been shattered, and we're living in a parallel world. Could the Large Hadron Collider be responsible for pushing us into a different timeline? What dark secrets are hiding behind this massive machine? Max Laughlin, a name that caught the world by surprise, isn't your average child prodigy. By the time he was 13, this young inventor had already designed a free energy machine. But that's not what stunned the scientific community. It was his theory about CERN, the European Organization for Nuclear Research, and its powerful Large Hadron Collider that truly shook the world. Laughlin claims that CERN's experiments have done more than just split atoms, they may have cracked the very fabric of our universe. What does that even mean? The Large Hadron Collider is a massive machine designed to smash subatomic particles together at unimaginable speeds. This collision mimics the conditions of the Big Bang, which scientists hope will help them understand the origins of the universe. But Laughlin suggests that these experiments have unintended consequences. According to his theory, CERN's actions may have fractured our original timeline, plunging us into a parallel reality. To be clear, this is not proven fact. Many scientists are skeptical. However, Laughlin's argument is based on scientific principles. He claims that during one of CERN's experiments, a critical anomaly occurred, throwing us into an alternate version of our reality. Allegedly, this shift could explain strange phenomena, like the Mandela effect, a theory that large groups of people remember historical events differently from how they actually occurred. Could this really be the result of the LHC disrupting our timeline? CERN, of course, denies these allegations. The organization has repeatedly stated that their experiments are safe and that the risks have been carefully calculated. However, Laughlin isn't alone in his concerns. Some scientists, particularly those skeptical of the Large Hadron Collider's safety, have warned about the potential dangers of creating black holes or even rupturing space-time itself. This isn't the first time CERN has been caught in controversy. Back in 2008, when the LHC first became operational, some physicists, including Francesco Calogero, expressed concern about its potential to generate catastrophic black holes. An article titled "Might a Laboratory Experiment Destroy Planet Earth?" penned by Calogero, ignited a firestorm of debates. Some experts even went on record suggesting that the collider could open a gateway to another dimension or universe. As wild as it sounds, it added fuel to the public's fears. CERN scientists, however, repeatedly refuted these claims, insisting that the chances of creating a world-ending black hole were astronomically low. But what if Laughlin's theory holds a grain of truth? Could our universe have been altered by CERN's quest to recreate the Big Bang? And if so, what other signs? Laughlin points to the Mandela effect as possible evidence. The Mandela effect, named after Nelson Mandela, refers to the phenomenon where large groups of people remember an event happening differently than it did. For example, many people distinctly recall Mandela dying in prison in the 1980s, despite the fact that he lived until 2013. Could this mass misremembering be a glitch caused by CERN's meddling with the fabric of reality? Let's not forget that Laughlin isn't just speculating in a vacuum. His free energy machine, built when he was just 13, suggests that this kid has a deep understanding of complex scientific concepts. So, while his theories may seem far-fetched, they can't be dismissed outright. It's worth noting that Laughlin himself hasn't claimed to have all the answers, but his ideas have sparked intense debate in the scientific community. Some CERN researchers have gone as far as to say that we could be living in a multiverse, a theory where an infinite number of parallel universes exist alongside our own. In fact, CERN's own experiments are partly designed to explore these very questions. But here's the real kicker: what if CERN did break our reality, and we didn't even notice? Could we be living in a different version of our world without even realizing it? The Large Hadron Collider is, without a doubt, one of the most powerful machines ever built by humanity. It stretches across a 17-mile underground tunnel near the French-Swiss border and is designed to smash particles at near-light speeds. This machine has led to groundbreaking discoveries, including the confirmation of the Higgs boson, or God particle, which helps explain why particles have mass. But with great power comes great responsibility and controversy. Max Laughlin's theory about CERN shattering our universe isn't the first time the LHC has been accused of catastrophic consequences. When the machine was first turned on in 2008, a wave of fear spread across the globe. Some people believed that the LHC could create a black hole powerful enough to swallow the Earth. Scientists at CERN dismissed these claims as science fiction, but the concerns were so pervasive that it reached the media and even sparked lawsuits aimed at halting the collider's activation. One of the most famous figures warning about the LHC was Walter L. Wagner, a nuclear physicist who filed a lawsuit in Hawaii to stop the LHC from operating. Wagner feared that the collider's experiments could trigger a chain reaction that would collapse the Earth into a singularity. The case, of course, didn't go anywhere, and the LHC continued its work. But the fact that a professional physicist was willing to go to such lengths demonstrates just how polarizing this machine has been. Despite these fears, CERN pressed on. The LHC was activated, and the universe didn't implode. However, the machine's capabilities are still far from fully understood. While CERN claims that it operates under safe conditions, others, like Laughlin, suggest that the real danger isn't a black hole but a shift in the fabric of reality. According to Laughlin, when the LHC smashed particles together, it didn't just recreate conditions from the Big Bang, it may have altered the very structure of the universe. The idea that something so small could have such massive consequences seems hard to fathom, but in the world of quantum physics, the line between reality and possibility is much thinner than we'd like to believe. Interestingly, Laughlin's concerns aren't based on pure speculation. The science behind particle collisions is incredibly complex, and while scientists understand the general outcomes, the LHC has produced results that even CERN's researchers struggle to explain. One notable example is the unexpected discovery of X-particles, a phenomenon that has left scientists puzzled. These particles, which emerged during collisions in the LHC, don't fit into any existing model of physics. What if these anomalies are signs that the universe isn't behaving the way it should? Adding to the intrigue, CERN scientists themselves have openly admitted that the LHC could potentially discover, or create, new dimensions. The idea that our universe could be one of many parallel realities isn't just science fiction anymore, it's a real hypothesis that many physicists are exploring. Could CERN have accidentally opened a door to one of these alternate realities? If so, what does that mean for us? And more importantly, could we ever return to our original timeline? As wild as it sounds, this theory would explain the strange phenomena that some claim have occurred since the LHC's activation. Max Laughlin's idea that the collider has shattered our universe is based on the premise that our reality has been altered in subtle ways. From the Mandela effect to unexplainable shifts in global events, people are beginning to question whether the world we live in today is the same one we inhabited before the LHC started its experiments. But what exactly would a shattered universe look like? According to Laughlin, we may not notice major changes, at least not right away. The idea is that the LHC has nudged us into a parallel timeline that closely resembles our original one, but with slight differences. This might explain why people remember events like Nelson Mandela's death happening decades before it actually did. It's a chilling thought. If this is the case, the implications are staggering. Could CERN have truly shattered our universe and thrown us into an alternate version of reality? And if so, is there any way to undo what's been done? One of the most compelling arguments for Max Laughlin's theory is the Mandela effect, a phenomenon that continues to baffle people worldwide. Named after Nelson Mandela, this effect describes instances where large groups of people remember something that differs from the documented history. The most famous example is the widespread belief that Mandela died in prison in the 1980s, even though he actually passed away in 2013. This is more than just a faulty memory. Whole groups of people vividly recall events that seemingly never happened. What makes the Mandela effect even more eerie is that these misremembered events often involve major historical figures or cultural milestones. For example, many people swear that the children's book series *The Berenstain Bears* was once spelled *The Berenstain Bears*. Others remember iconic movie quotes differently than how they actually appear, like Darth Vader's famous line in *Star Wars*, "Luke, I am your father." These collective, false memories have led some to believe that we are living in a parallel universe where small details have been altered. Max Laughlin believes the Mandela effect is a direct consequence of CERN's experiments. He suggests that when the Large Hadron Collider was activated, it fractured our timeline and created ripples in the fabric of reality. These ripples, according to Laughlin, have caused our memories to bleed over from other parallel universes. In other words, the Mandela effect might not be about faulty memory at all, it could be evidence that we are experiencing fragments of an alternate reality. This theory is, of course, highly speculative and remains unproven. However, it has gained traction among conspiracy theorists and even some scientists who are open to the idea of a multiverse. The concept of parallel universes isn't as far-fetched as it may seem. In fact, physicists like Dr. Michio Kaku have long speculated about the possibility of alternate dimensions coexisting alongside our own. According to string theory, the multiverse is not only possible but could explain some of the most puzzling aspects of quantum mechanics. But here's where things get even more unsettling. If Laughlin's theory is correct, and the Mandela effect is the result of our timeline being altered, what other changes might have occurred that we haven't noticed? Could there be major historical events that have shifted without our awareness? And if so, how would we even know? The idea that we are living in a parallel universe raises more questions than answers. For instance, if our reality has been altered, what was the original version of our world like? Is it possible to compare the two? Or are we forever trapped in this new version of reality, never able to return to what once was? Moreover, the Mandela effect isn't limited to just a few examples. New instances of collective false memories continue to emerge, with people reporting everything from altered brand logos to differences in famous historical speeches. Whatever the answer, it's clear that the Mandela effect has captured the imagination of people around the world. CERN's most ambitious mission with the Large Hadron Collider is its attempt to unravel the mysteries of dark matter. Dark matter is one of the biggest enigmas in the universe, something we cannot see or detect directly but know exists because of its gravitational effects. Scientists estimate that around 85% of the universe is made up of dark matter, yet we have no idea what it is. The stakes are high, and the LHC is one of the few tools capable of probing the deep cosmic mystery of dark matter. Dark matter first entered the scientific spotlight when astronomers observed that galaxies don't behave the way we would expect based on visible matter alone. Galaxies rotate too fast for the amount of mass we can see, suggesting that some invisible substance is exerting gravitational pull. This substance is what we now call dark matter. Although its presence can be inferred from these gravitational effects, all attempts to directly detect or study it have so far failed. This is where CERN hopes the LHC can change the game. The LHC's role in this quest is to collide particles at incredibly high energies, creating conditions similar to those just after the Big Bang. Scientists believe that in those early moments, dark matter might have interacted more visibly with regular matter. The hope is that by recreating these conditions, we can finally observe dark matter particles. But the quest has been fraught with challenges. Since its completion in 2008, the LHC has performed two major runs, both of which failed to yield any definitive evidence of dark matter, despite some promising hints. One of the primary theories about dark matter is that it consists of weakly interacting massive particles, or WIMPs. These hypothetical particles are thought to interact only through gravity and the weak nuclear force, making them incredibly difficult to detect. The LHC has been hunting for WIMPs for years, but has yet to find any conclusive evidence. This lack of results has led some scientists to wonder whether we are looking in the wrong place, or perhaps, the wrong way. The search for dark matter took a significant turn in 2012 when the LHC confirmed the existence of the Higgs boson. This discovery was groundbreaking because it validated the standard model of particle physics, which describes how the basic building blocks of the universe interact. However, dark matter doesn't fit neatly into the standard model, leaving scientists puzzled. Could there be forces at work beyond our current understanding of physics? Some researchers believe that dark matter might be linked to hidden dimensions or parallel universes, much like Max Laughlin's theory about the Large Hadron Collider opening portals. If dark matter interacts with other dimensions, it might explain why we can't detect it using conventional methods. CERN's experiments are designed to explore this possibility, but as of now, dark matter remains elusive. What's more, some critics argue that CERN might be keeping certain discoveries under wraps. After all, the implications of uncovering dark matter, or revealing evidence of hidden dimensions, could fundamentally change our understanding of the universe. Are there secrets that CERN is hesitant to reveal to the world? As the LHC continues its quest to uncover dark matter, one thing is clear: this mysterious substance holds the key to unlocking some of the deepest secrets of the cosmos. **** Mysterious X particles discovered, they are clue to the universe's origin. In recent years, one of the most baffling discoveries to come out of CERN's experiments is the identification of X particles, an entirely new type of particle that defies current scientific models. These particles were detected during the LHC's second run, buried among billions of other particles produced in the collider's extreme conditions. But what exactly are X particles, and why do they matter? The discovery of X particles took the scientific community by surprise. These particles, which were found in the quark-gluon plasma, a hot soup of fundamental particles that existed right after the Big Bang, seem to challenge our understanding of how the universe evolved. Quarks and gluons are the building blocks of protons and neutrons, the particles that make up the nuclei of atoms. However, X particles are different. They are incredibly short-lived and do not fit into any existing model of matter. What makes X particles particularly intriguing is that they could hold the key to understanding the earliest moments of the universe. Scientists believe that shortly after the Big Bang, the universe was a chaotic, trillion-degree plasma where quarks and gluons floated freely. As the universe cooled, these quarks and gluons condensed to form more stable particles, such as protons and neutrons. However, a tiny fraction of these particles formed into X particles, whose exact nature remains a mystery. The implications of this discovery are massive. If scientists can determine how X particles form and behave, it could provide a new understanding of how matter in the universe came to be. This discovery might even help explain why the universe is made primarily of matter, as opposed to antimatter. But for now, X particles remain enigmatic, fleeting ghosts of the early universe that scientists are struggling to understand. What's truly remarkable about the discovery of X particles is how difficult they are to detect. In order to identify them, CERN scientists had to sift through 13 billion particle collisions, a monumental task. Each collision produced a burst of quark-gluon plasma, and only a tiny fraction of these events resulted in the formation of X particles. Detecting these particles is like finding a needle in an infinitely large haystack, yet CERN managed to do it. The discovery of X particles has prompted some scientists to wonder whether they might be linked to other mysteries, such as dark matter. Could X particles be related to the elusive dark matter that makes up most of the universe? It's too early to say, but the potential for groundbreaking discoveries is enormous. X particles could offer new insights into both the early moments of the universe and the dark matter that holds galaxies together. CERN researchers are now focused on studying X particles in greater detail, hoping to unlock the secrets of their formation and behavior. If successful, this could lead to a major breakthrough in our understanding of the universe's origins. But like dark matter, the nature of X particles remains mysterious. Do you think CERN's experiments are unlocking the mysteries of the universe or potentially opening doors we shouldn't cross? Let us know your thoughts in the comments below. If you enjoyed this video, don't forget to hit that like button and subscribe for more awesome content. Stay curious, and we'll see you in the next one.